I'm faculty here in the Environmental Occupational Health Department, and it's my pleasure to introduce John Haynes, who is here locally from NASA. It's great to have you in town here. I met John a little bit ago through his work at the NASA Applied Science Office. He's been running the Health and Air Quality Applications work, which has just been expanding and has been really successful over time. And I just learned an interesting fact about John, which is that he started in the government as a presidential management fellow, which I did as well. So I encourage you to say a few words about how you felt that program and how it facilitated your entry into the federal government. And I'm happy to talk with any students who are interested in that program as well. It's for recent master's graduates, so it's really actually perfect. So John is here today to talk about NASA remote sensing and its applications for public health.
Thank you all for being here and taking time and at least getting some lunch to come here on me speak. And before I get into the talk, I will, so I don't forget, talk a few words about the Presidential Management Fellowship Program as well. And the PMF program was started by President Carter and expanded by President Reagan in the 1980s. It basically provides an opportunity for graduating master's and PhD students to enter the federal government on a fast track. So it is a competitive process. It used to be that your school nominated you, but now you can actually self-nominate yourself through the OPM website. And then they go through all the resumes and all the applications, and then they actually have civil service boards interview all the applicants, and also you do other types of kind of your guinea pigs, if you will, in a way. They'll put you in a room and give you a problem, and they'll sit there and judge how you work better with groups and things like that. It's kind of interesting from a psychological point of view, I suppose. After all of that, they will choose their finalists. And as a finalist, you're not guaranteed a job, but you're guaranteed the opportunity to apply for a job at agencies that have a billet open for PMF. And if you get accepted by that agency, it's a 2-year fellowship. At the end of the 2 years, if you're happy and they're happy, you just convert immediately to civil service. And you know, you've already done your probationary period, and typically now they would jump you up to start at a GS-12, I believe. When I was there, it was GS-9, but now it's GS-12. So it's a really great opportunity, and it's a very fast track in the federal government. That was what it was meant to be, to get the best and brightest into the federal government on a fast track to compete with the government, to be able to compete better with private industry and be able to provide the government. Also, after the end of my talk, you can also talk to Helena Chapman. Helena Chapman is my AAAS fellow for Health and Air Quality Application at NASA headquarters, and AAAS has a similar fellowship program. It doesn't convert civil service at the end of 2 years, but it's a 2-year fellowship at government agencies at the AAAS runs. So Helena can sure be glad to talk to you more about that. So again, I'm John Haynes. I'm Program Manager for Health and Air Quality Applications at NASA headquarters, part of the Applied Sciences program. Over the next, I guess, I have to 1:30, so I guess I'll say over the next 45 minutes, so we have time for questions. Most people would say they're going to give you a 30,000-foot overview of their program, but at NASA we say we're going to give you a several 100-kilometer high overview of our program, because for NASA, and there we go. Big reveal now. Because it all starts here for us. It all starts several 100 kilometers above our head with our constellation of 18 satellites and sensors in low Earth orbit, continuously monitoring Earth's weather, climate, and environment for research and applications purposes. This constellation of 18 satellites, along with sensors aboard the International Space Station, represents the largest Earth remote sensing, non-military Earth remote sensing constellation in the world. It also represents an investment of about $2 billion, that's $2 billion with a B per year by the American taxpayer, making NASA also the largest contributing federal organization to the United States Global Change Research Program, USGCRP. For those that you may not know about USGCRP, it is congressionally mandated. It's mandated by law, the Global Change Act of 1990. It is a consortium of 13 federal agencies that either have a mission that is affected by climate change or a mission to study climate change. And among USGCRP, there are many different working groups, including one dedicated to climate change and human health. It's the CCHHG, we lovingly call it the CHIG. And NASA, I serve as NASA's rep on that working group. It's actually chaired by John Balbus of NIH, some of you may know. So again, the animation is a very cool animation, and it's probably over now, about how our satellites orbit. For those of you, again, I know we're trying to get more and more help into remote sensing, it's bridging that gap. But again, just to kind of go back to first principles, why are satellites in low Earth orbit, and what does that mean, and why do we orbit them that way? It's because it's a little bit different than what you probably think of when you think of satellite data. If you think of satellite data looking at WJLA or WRC at night or the Weather Channel, and you see the big satellite image of the United States that meteorologists are always showing, that is actually an image from a geostationary satellite. So a geostationary satellite, here's the Earth, and a geostationary satellite is about 25,000 miles away from the Earth's surface. And it's at a point where it is exactly moving at the same speed of Earth. So the geostationary satellite is always looking at the same point on Earth as Earth revolves. So for our weather satellite, it's always looking at the United States. That's really great because it gives us 24 hours coverage. So we can see hurricanes forming and how they move across the Atlantic and how weather systems are coming down from Canada, et cetera, and so forth. But it's a little bit different when we're wanting to get a global image of the environment and how the environment is changing, and how our Earth is dynamically changing. And that's why we do low Earth orbiting satellites. What they do is they go over the poles, and Earth revolves underneath them. So you're talking about like if you were peeling an apple, and those are strips of data. If you were turning that apple and continuing to peel it, when you put all those strips together, you get the whole surface of the Earth. And so we're doing that so we get a global picture of the Earth, not just of one side. So we're able to, again, build those data sets and have for decades to see how Earth is changing over time. So if we want to go a little bit deeper and look at these satellites, what you're looking here is the current constellation, the ones that might be a little hard to see, but it's the ones in blue and gold. So these colors are the ones that are currently in orbit. The warmer colors, the oranges and the yellows up here, are the ones that we're planning on launching from now until about 2023. Because we build these satellites to last, and they're kind of like the Energizer Bunny. Most of them are operating beyond their prime normal expected lifetime because we build them to last. But eventually they will fail. And so we always have to be planning ahead of what are going to be the new satellites that we want to launch over the next few years to keep this the most robust constellation in the world. So when you're looking at these satellites, and plus the ones that we have up on the International Space Station as well, you're going to hear me talk about a few of them over and over. So I'm just going to point those out. Right now, 3 of them are our flagships. We call them our flagships because they have multiple sensors on board, looking at Earth through different instruments. One is called Terra, primarily looking at the Earth's lithosphere, the land masses. One is called Aqua, primarily looking at Earth's oceans. And the other one is called Aura, primarily looking at the Earth's atmosphere. So you'll hear me bring those up several times, particularly one instrument on Terra and Aqua itself, which is called MODIS. MODIS is the Moderate Resolution Imaging Spectroradiometer. Say that 5 times fast. You see why we like acronyms at NASA. That's a mouthful. But MODIS, I guess, deserves having such a long name because it's really a workhorse for the program. It looks at the Earth in over 30 different wavelengths, the electromagnetic spectrum. We get everything from land surface temperature to land use and land cover changes on Earth from MODIS, to how dense vegetation is, to temperatures of the ocean surface, to ocean color, looking at phytoplankton in the oceans. In the infrared spectrum on MODIS, we get wildfires. We're able to see fires across the surface of the Earth. We get aerosol optical depth from MODIS to see what is the loading of particulate matter in columns of the atmosphere. So we really get a ton of information from that one sensor on 2 spacecraft. And we also on Aura, you'll hear me probably talk a lot during this presentation of the ozone monitoring instrument on Aura, OMI, which is actually a contribution from the Royal Dutch Meteorological Institute. Many of our satellites in orbit are through international collaboration. It really takes a planet to study the planet. So the OMI instrument, ozone monitoring instrument, is a contribution on that satellite from the Dutch. And what does OMI stand for? What does OMI study, do you think, the ozone monitoring instrument? I always ask that people look at me, and I'm like, it's not a trick question. The ozone monitoring instrument monitors ozone. Obviously very important. NASA has been continuously monitoring the ozone, the total columnar ozone on Earth, since the late 1970s. We're actually required by law to continue those measurements because, thanks to those measurements, we were actually discovered the Antarctic ozone hole in the late 1970s and then understood that chlorofluorocarbons were destroying it. So we continuously monitor ozone. But the other important thing on OMI is that it looks at other constituents of the atmosphere. It looks at nitrogen dioxide, it also looks at sulfur dioxide. So we get a lot of atmospheric composition information from the ozone monitoring instrument. When you're talking about, again, international cooperation, for example, the Global Precipitation Mission, GPM, that's actually in cooperation with the Japanese space agency, JAXA, looking at rain and snow totals across the surface of the planet. The Calypso. Calypso is an on-orbit LiDAR. It basically, think of it as a laser radar, if you will. Has a laser on board that goes and looks at the Earth's surface so we can get vertical information on aerosols in the atmosphere. So we not only know how much total aerosols are in the atmosphere from MODIS, but thanks to Calypso, we can see how they're distributed in 3 dimensions. And that's a contribution in collaboration with, I should say, the French Space Agency CNES. So you can see it takes really a whole globe to make this constellation possible. And like I said, we have to continually keep this constellation robust by building, planning, and launching new satellites. So just in the last year, we had 2 launches. We had the launch of SPH-GWU, which that stands for the Stratospheric Aerosol and Gas Experiment, the 3rd one in a series of these sensors, that, as it says, will look for ozone in the atmosphere, and also included a lightning imaging sensor that was launched to the International Space Station in February aboard a SpaceX Falcon 9 from Kennedy Space Center. The lightning imaging sensor, for example, we've already found some just fascinating information from it. For example, the average number of lightning strikes per second on Earth. How many lightning strikes do you think hit Earth per second? Just take a guess. 100? It's 47. 47 strikes on average. Every second. Every second. Think about that. And that's what we're already finding out from the lightning imaging sensor. Then we had the launch of the Joint Polar Satellite System, #1, JPSS, from Vandenberg Air Force Base in November. JPSS includes a lot of the next generation, I'll say, of sensors that are on MODIS, that are on Terra and Aqua. Instead of MODIS, VIRS is included on JPSS, and it's a next generation version of MODIS, for example. JPSS also includes the ozone monitoring, another ozone monitoring instrument known as OMPS. So it's a kind of the next generation of a lot of the ones I was just talking about. And this is in a collaboration, what's called the Joint Polar Satellite System, because it's in collaboration with the National Oceanic and Atmospheric Administration, NOAA, our nation's operational weather service organization. And like I said, it takes a planet, but it also takes a planet working together to have many of these satellites fly in constellation. And we'll get to why that's important. We have 6 of our U.S. and international satellites flying one right after the other in the same orbit. It's called the International A-Train. A-Train stands for afternoon because it passes the equator, depending on where you are on Earth, in the afternoon, about 1:30 local time. And these, again, it starts out with Aura. 6 minutes later, Calypso comes over. Then, 1 minute later, CloudSat comes over, which is primarily a weather and cloud aerosol satellite. Just a little bit later, here comes Aqua. Then GCOM, which is a Japanese satellite looking at carbon. And then less than 2 minutes after that, the orbiting carbon observatory. Why do we do this? It's because we can harness all the data from these satellites and layer them one on top of the other. So we're getting an almost simultaneous picture of the Earth from 6 different satellites at once as they stream several hundred kilometers above our heads. So that really is important to layer that data, gets more richness, more fullness, and understanding, again, how the planet is changing. And these are all the countries that are involved in that constellation. So let's just take a look at some of the data, just a few examples of what we can see when we're talking about using this Earth science satellite data from the constellation. This is an image from MODIS in the visible spectrum. So this is much like what you would see if you turn on the Weather Channel right now to look at the weather across the United States. So this is a visible image from MODIS back in July of 2004. And if you were just to look at this visible image of MODIS, and you look here in the central United States, you see, maybe it's clouds, maybe it's fog. You're not really sure. It just looks like some type of, low cloudiness. And if all we had was the visible data, that's all we would know. But remember I mentioned that MODIS looks at over 30 different wavelengths of that electromagnetic spectrum. And one of those was aerosol optical depth, where it can actually look at the loading of particulate matter in the atmosphere. Well, when you overlay that, you see that that's not cloudiness at all. It's actually particulate matter, it's smoke, that was being ejected by the jet stream from Alaska and the Yukon Territory in Canada, wildfires up there. And the smoke was actually being ejected into the central United States. And we get that from MODIS AOD data. And then the dots you see are the ground data from EPA. Because we'll know how much is the loading of the smoke and the aerosols in a column in the atmosphere, but we also want to know how much of that is getting to the ground where we're actually breathing it. And so that's where the EPA data comes into play on the ground. Again, satellites from our unique global vantage point from orbit are a huge piece of this environmental puzzle. But I always like to point out they're not the only piece. They're just one piece of the puzzle. It takes everything from ground data all the way up to orbit to get a complete picture of how Earth is changing. Another satellite that we actually are in, it's actually in cooperation again with the French Space Agency CNES, is the Ocean Surface Topography Mission, OSTM, JSON-2. And it's looking at how sea level is changing across the planet. And we're talking about down at the millimeter resolution level. So obviously very important for climate change issues. But when you heat up a column of water, it expands. That's why we're having climate change and sea level rise. When you cool down a column of water, it shrinks. It's very important to have this information when you're looking at how the globe changes with natural cycles like El Nino and La Nina. Because El Nino is a warming of the waters off the coast of South America, and that causes the column of the ocean to rise there. So using OSTM data, we were able to see in 2009 and 2010 sea level rises occurring here over the coast of South America, off the coast of South America, which was the first signs of an El Nino developing that year. It's very important for meteorologists to know about El Nino and La Nina because that cooling or warming off the South American coastline impacts weather patterns worldwide. If you have a very strong El Nino, it typically leads to, for example, very heavy rainfalls in the western United States and California, where they call it like the Pineapple Express comes in and all that Pacific moisture is just hitting the mountains constantly. It also typically causes very strong storms to develop in the Gulf of Mexico and right up the eastern coast of the United States, those typical nor'easters. That's just the effects on North America. And if any of you were here during the winter of 2009, 2010, you might remember that DC was hit by 3 blizzards that year, over 60 inches of snowfall total that year. I think we were out of the government for 2 weeks at one point. Very different than this year, where we haven't even had 1 inch of snow total in Washington, even though it's been so cold. But this is a strong La Nina year. The South American waters have cooled. So that just shows you how it really changes your winter weather, depending of something that's going on 5,000 miles away. We also are able to take a look at disasters and healthy disaster response, working with FEMA, working with NOAA. We can do this, one of the ways we can do this is by taking data from NPP, which is similar data to that Joint Polar Satellite System that I was mentioning earlier. They're very similar satellites. But NPP and JPSS have a night band on them, a day-night band. So we're able to actually look at night lights across the surface of the Earth. And that becomes very important when you're talking about disaster response after hurricanes. Because here was, again, an image on the day-night band from NPP where we were actually able to provide data to FEMA and to the U.S. military on where the highest density of power outages were across the New York metropolitan area after Hurricane Sandy. So why were we able to do this? So the yellow areas, it's a little hard to see, but the yellow areas are where lights were missing. So they took an image of New York night lights before Sandy, and then the day after Sandy. Where are those lights missing? And then you're able to come up with a data product that shows, based on the missing lights, how much of the power is out in these areas of Long Island, New Jersey, and New York. It's very helpful information when you're talking to power companies and FEMA. Global Precipitation Mission, GPM, that I mentioned, which is in collaboration with the Japanese Space Agency. This is just one of the examples that we can get from that, where we're actually looking at Hurricane Joaquin here. This was a couple years ago. Hurricane Joaquin was probably best remembered for there was a very large ocean tanker that sank when it accidentally ran into the storm, not paying attention to the forecast as well as they probably should have. But also, during its landfall in the Carolinas, it dumped almost 27.5 inches of rain in the Bahamas and almost 2 feet of rain in the Carolinas. So we were able to get, again, information on that from the Global Precipitation Mission satellite. So that's just a few high-level examples. To talk about where we applied scientists fits into this puzzle is the NASA Earth Science Division has four divisions. One is flight. The flight division is in charge of building, procuring, and launching all these satellites. That's their job. So they're the first piece of the puzzle. Then after they're launched and they're operating, come in the research and analysis division, RNA. RNA takes all this first level data coming down from orbits and makes the products and studies it and to answer our 20+ research questions that are required by the NASA science plan on how is Earth changing, how is our climate changing, how is our environment changing. So they're taking that data, crunching it, making the first level products, and answering those basic science questions, which is NASA's primary charters. Then we move over to my program, the Applied Sciences program, where all the data and products that are coming from RNA, we take it one step further. And we take those and make them meaningful for societal benefit. Working with different organizations, being in the private sector, public sector, at the international, state, local level, you name it, to try to get NASA's information beyond basic research and being applied to benefit society, to have people do better management and policy decisions. And then we also have the technology office, Neuroscience Technology Office, ESTA. They're in charge of coming up with new technologies and testing them, typically on airborne campaigns. So those will be the next generation sensors that will eventually be launched to orbit. So it kind of all moves together. And like I said, Applied Sciences, where I am, our mission is to discover and demonstrate innovative and practical uses of Earth observations in organizations' policy, business, and management decisions. You can really think of us as this bridge. We're the bridge between all the results of NASA science research, that technology office, all the technology that they're developing, those 18 missions that are occurring in orbit, and all the literal terabytes of data every day we're downloading from orbit from those. Our data and archive system. There are over 10 distributed active archive centers across the United States that are taking all those terabytes of data and archiving it and making it publicly available across the globe. The research and analysis program that is doing that basic first level research on that data as it's coming down, and our model predictive capabilities. NASA has some of the fastest and largest supercomputers in all the world. For example, we have the Pleiades cluster at NASA Ames Research Center in Silicon Valley. That is one of the fastest in the world, and we require that data to be able to run these, we require that power to be able to run these climate models. And then all the needs of society. We need better management decisions. We need better policy decisions. We need better forecasts. We need better response and recovery to natural and man-made disasters. So Applied Sciences was formed in 2001 at NASA to help be this bridge. And it was actually in direct response to a National Academy study in 1998 that said that there was this chasm, this valley of death, they put it, where good research in the government went to die and never got pushed into operations. Because you have research arms of the federal government, like NASA and like NIH, then you have operational arms, like NOAA or like FEMA. And they said there was this gap where you couldn't get all this great research being done over to the people who needed to make better decisions. And so that's where we come in, hopefully, successfully, over the last 15 years, bridging that valley. And we do all these activities in 6 areas of emphasis. Of course, my area being health and air quality, but we also have a water resources program, an ecological forecasting program, a disaster management program, and an agriculture and food security program. Up until last year, we had a wildland fire portfolio. That was kind of a one-off thing. It wasn't meant to continue forever. So any other wildland fires proposals that we get in now are actually being reclassified into ecological forecasting and disaster management. We also support opportunities in energy, urban development, and transportation infrastructure as our budget and capacity allow. One of the things that has been a huge success in working with a federal partner has been our SEVERE program. SEVERE is in partnership with U.S. Agency for International Development, USAID. And it is, at its heart, a capacity building program, where NASA has partnered with USAID to establish these nodes across the developing world in order to bring together stakeholders in that region of the world and NASA data to help answer questions about their current environmental status and to tackle issues that are of importance to their region. So we have nodes in Central America, one in Eastern Africa in Niger, one in West Africa in Nairobi, one in Kathmandu, Nepal, and one in Bangkok, Thailand, for Southeast Asia. And all of these nodes are in cooperation with an international consortium for that region. For example, the one in Kathmandu, Nepal is in cooperation with ICIMOD, which is a consortium of all the Himalayan states. And for example, they're looking at issues of glacier retreat. They're looking at issues of air quality. And sometimes those go hand in hand. One of the projects that they looked at was the amount of black carbon being deposited on glacial sheets in the Himalayas, coming from air pollution in China and India. Not only is that bad to breathe, you don't want to be breathing black carbon, but by depositing a thin level of black carbon across the glaciers, well, if you have sunlight on a white surface, it reflects. Sunlight on a black surface with black carbon on top of the glaciers absorbs heat, and it's actually accelerating glacial retreat in the homelands. So why do we have, and so that was just one example, I wanted to throw that in, of health and air quality internationally with USAID. But kind of fundamentally, why do we have a health and air quality program at NASA? And we have since the very beginning, since 2001, when Applied Sciences was formed. Because of the potential health effects of climate variability and change. So both natural and anthropogenic climate change can lead to regional weather changes, changes in heat waves, changes in urban heat islands and metropolitan areas, changes in precipitation and temperature regimes, changes in air pollution levels, contamination pathways, and transmission dynamics that lead to all of these different types of health effects. So this is the #1 reason, again, why from the very start we had a health and air quality program at NASA. We also have the issue of global emerging and re-emerging diseases. This map came from Nature in 2004, I believe, and we could just add more diseases to this map. For example, Zika. NASA certainly can't tackle all these diseases. In fact, we can only tackle the infectious and vector-borne diseases that have some type of environmental parameter behind their spread, or behind the spread of the vector, that we can also remotely sense from space. So you have to meet those 2 criteria before we can work with a partner in tackling risk characterization for that disease. And unfortunately, new environmental threats rear their ugly head all too often. This is a MODIS, again, visible image of the Deepwater Horizon oil spill off the central Gulf of Mexico coastline in 2010. One of the unfortunate, it was interesting and unfortunate at the same time, that we learned from this oil spill was it was so large and in such a warm environment that when we looked at data from Calypso, and remember Calypso was the on-orbit LiDAR that's in cooperation with the French Space Agency, we all saw aerosols, the gassing off of this large oil spill. It was all these volatile organics. And it was because of the large size of the oil spill and being in a very warm environment. So these volatils are degassing off the oil spill. They're combining with nitrogen oxides to produce ozone. Then the sea breezes were actually ejecting that ozone onshore from New Orleans, Biloxi, Gulfport, Mobile. And this was confirmed by EPA ground sensors. So we were able to work with the EPA and with state and local authorities to help warn people that are particularly respiratory compromised to stay indoors because of these high ozone levels that are being directly caused by the oil spill, something that we had never seen before. So the Health and Air Quality Program's main missions are to support the use of Earth observations and air quality management and public health, particularly regarding infectious disease and environmental health issues. We also use Earth observing data and models for to support the implementation of air quality standards, policies, and regulations. And we also address the effects of climate change on public health and air quality to support managers and policymakers in their planning and preparations over the next 5, 10, 15 plus years. So we currently have 29 active projects in the portfolio, and I'm going to step through each one of them now. I always like to see the people's look of fear. Just going to go through a couple of them and give you an idea of what we do. For example, this was a project in partnership with the National Oceanic and Atmospheric Administration, Dr. Richard Stump. And again, notice that all of our projects have to be in partnership with an operational partner who is making a decision, and they need NASA's help to make that decision better. So you might remember this. It was a project to look at harmful algal blooms in Lake Erie. And harmful algal blooms are harmful because they release toxins. These are cyanobacterial algal blooms. They release a toxin into the water that is not only dangerous for us to drink, it can be deadly actually to pets. If you have a pet running along the beach of Lake Erie and drinks the water, they can die of liver and kidney failure. So it's not something you want to mess with. And when you're talking about drinking water supplies, it is something that can be counteracted using activated charcoal, for example, if you know in time to treat your municipal water supply with it, that a harmful algal bloom is coming along to hit you. Well, you might remember this, in 2014, Toledo had to issue a do not drink order for its entire 400,000 residents because this harmful algal bloom on Lake Erie came into the water intake valves for the city of Toledo, and they had not treated with activated charcoal their water supply. Well, here's the timeline of events of us working with NOAA. On August 1st, we, through the Harmful Algal Bloom Bulletin of NOAA, using this data from NASA MODIS, because NASA MODIS, remember I said, can look at ocean color, which that means it can look at these algal blooms. We said on August 1st, we reported intensification of this harmful algal bloom in western Lake Erie. That gave Toledo the heads up that, hey, maybe we should test our water and see if any of these toxins have gotten into it. On August 2nd, they tested their water and found the microcystin in their finished water. They immediately had to issue the do not drink order and then brought in activated charcoal to treat their water, but it was several days before it was safe to drink again. They learned their lesson because in 2015 we saw a stronger algal bloom than this one, heading straight for the same water intake valves. Once again, we issued the warning to them that you better be taking a look at this very closely. And they, without waiting to test, they treated their water immediately with the chemicals that they had on hand. So they didn't have to go and issue that do not drink order in 2015. This was such a successful project with NOAA, and working with state and local authorities like the Ohio EPA, that we actually expanded it into Florida to look at red tides in Florida with Dr. Richard Stumpf again. The goal of this was in the same harmful algal bloom bulletin that NOAA issues, is to issue a respiratory forecast based on red tide likelihood for each beach every day on the Florida, Gulf of Mexico coastline. This is a different harmful algal bloom than the freshwater ones in Lake Erie that produce this toxin that makes drinking water bad. Harmful algal blooms, red tides off the coast of Florida, do that as well. They can kill marine mammal and fish and other types of marine wildlife. But the main harm to us as humans is that the red tide actually aerosolizes a toxin into the atmosphere that sea breeze will bring on shore up to 1 kilometer inland. And even if you're not respiratory compromised, you will suffer watery eyes, sneezing, sore throat. It doesn't matter. Everybody is highly allergic to it. And it doesn't make for a great day at the beach if you decide you're going to go to the beach that day and the red tide aerosols are in the air. So certainly the state of Florida, for a health reason, wants to know this information, and they also for a tourism reason want to know this information. So what we did was we actually took data, again from MODIS and VIIRS, that ocean color data, along with information from NOAA's HAB forecasting system and their National Forecast Digital Database. And we also combined it with a new interesting technique that's kind of a research and a citizen science technique called HABscope. And this is in partnership with the Moats Marine Lab in Sarasota. They developed a filter for cell phones, smartphones, with an app that anybody can go get a sample of Gulf water, put the filter over the camera lens, take a picture, and send it to Moats Marine Lab. And their scientists will look to determine if the harmful algal bloom bacteria is in that water sample. They can tell from that image. So instead of them having to go out from Sarasota and do these in situ samplings, maybe they get to each beach once a month. They now have everybody from lifeguards to anybody can send them the data. So you're combining that data with the satellite data, so everything, again, from the ocean surface up to orbit. And we launched for the first time ever on October 31st, the new harmful algal bloom bulletin, combining all this data, and we're now having respiratory distress forecasts along the Florida Gulf Coast 1 to 2 times per day. Been so successful, it's about to be expanded into Texas, looking to scale into Texas. And again, because of the success of all of these types of work with NOAA, we actually have begun a 5-year consortium of NASA, EPA, the U.S. Geological Survey, and NOAA to create a uniform and systematic approach for looking at harmful algal blooms, those cyanobacterial freshwater blooms, across the entire continental United States. So taking the lessons we learned from Lake Erie and applying them to the entire country as well. Another issue of water quality and health was a study that we did with the Louisiana Department of, I think it's Health and Hospitals is their agency, along with Louisiana State University, to look at water quality in the oyster beds of Louisiana. Well, particularly talking about norovirus. And what environmental data could we have that would give a heads up to the Department of Health officials of where they need to test for norovirus in the oyster beds? Because their system before this was just to randomly test through these 30 some odd beds and come back here and just kind of go in line. Well, you could easily have a norovirus outbreak in the water here in bed number 28, and maybe you're testing over here and you're not going to get to that until it's already gone. So it would be make more sense if we could know what environmental parameters cause norovirus outbreaks. So you could say these oyster beds have a higher risk. So that's the ones you need to go test. And so we actually used data, from MODIS, Oterra, and Aqua. We looked at data such as ocean surface temperature, and again, bacteriological data from field sampling to develop a predictive model. And we found out that the most sensitive environmental factors for norovirus was sea surface temperature and low tide or gauge height. And combining this data, LSU, was actually able to successfully predict a norovirus outbreak in an oyster bed in December 2012. So it's provided great insights and one of the testimonials from the Executive Director of the Department of Health in Louisiana on how they do business down there. Talking about another issue on water cholera. We have a project currently with Dr. Antar Jutla at West Virginia University, working in partnership with the International Center for Diarrheal Diseases in Dhaka, Bangladesh, to take all of these types of Earth observation data and look at the different transmissions of cholera in Bangladesh. Because actually there's 3 different types of modes, if you will, of transmission of cholera in Bangladesh. Along the coast of the Bay of Bengal here, it's actually endemic all year long. In the Dhaka capital region, it's kind of mixed mode with 2 seasonal peaks, one related to seawater intrusion from the Bay of Bengal, and the second peak associated with widespread inundation during monsoons. And then in northern Bangladesh, it's epidemic but sporadic, usually following floods or inundation. But again, it is to work with the International Center for Diarrheal Diseases and the government of Bangladesh to develop a predictive model that they know which area is more at risk based, again, has it been seawater intrusions from cyclones, has it been inundations from monsoons, so they get a better idea of where they can expect cholera outbreaks throughout the country. And this has been so successful that we've actually worked with Dr. Jutla to expand this project into Eastern Africa, starting soon. Looking at malaria issues. So we've done a lot of work on malaria risk characterization in sub-Saharan Africa and Southeastern Asia. We've also worked very closely with the Ministries of Health in Peru and Ecuador on malaria risk characterization with Dr. Bill Pan at Duke University. 90% of the Western Hemisphere's malaria is in the Amazon, and 75% of those cases occur in northeastern Peru and the Department of Loreto. So looking again at issues of environmental issues such as rainfall from GPM, looking at issues of land surface temperature from MODIS, looking at issues of land use, land cover, we've been able to develop a predictive model for that region to determine how malaria risk changes through the year and how it changes in relation to different aspects of the environment, such as El Nino. El Nino has a large effect on malaria. In fact, during the last large El Nino year, it caused an epidemic of malaria in Peru. Because again, you're bringing in all the right environmental factors. A big challenge, though, in this project, I will say, is trying to link where people get malaria versus where they're diagnosed with malaria. That's been a big issue with the model that we're still working on, because people will go to work in deforestation and logging in this northeastern Loreto province, and they're probably acquiring malaria there, but then they go back home, and they're diagnosed at home. And so the data point says, this place has malaria. Well, no, it doesn't. Loreto did. They just got diagnosed at the other place. So that's been a big issue working with the Ministry of Health. I would encourage you, if you just Google NASA malaria Amazon, it'll be one of your first search results that pop up. We just did a new video on this project and released it on our website a couple months ago. I said we've also worked in sub-Saharan Africa with Ministries of Health in Eritrea and Columbia University to look again at malaria risk characterization using a lot of the same data points instead in sub-Saharan Africa versus Amazonia. Working with the Department of Health in California and Dr. Chris Barker at University of California, Davis to map Zika virus vectors in Southern California. His project originally started looking at emerging vector-borne diseases in Southern California, particularly dengue fever, but when Zika hit, he quickly pivoted, because the same mosquito vector that carries dengue that covers Zika, and that became, of course, the bigger hot topic of wanting to know what's the risk of Zika transmission here in Southern California. You know, there's a lot of environmental data that we can bring to play in helping the Department of Health understand what the risks are of these vectors so they have better decisions on where to spray, for example, and do vector control. But I always tell the story that sometimes pieces of data that you don't even think about are the important one, and you're overlooking it. In 2009, there was a very large outbreak of West Nile virus in Bakersfield County in California. This project was going on at the time looking at West Nile first in California before they moved on to dengue. But they couldn't understand because none of the predictive models they developed for the mosquito vectors showed that there should be any risk of West Nile virus whatsoever in Bakersfield, California. So what in the world's going on? So Dr. Barker and them actually purchased some extremely high-resolution commercial data to look at these neighborhoods in Bakersfield, California to figure out what was going on. And he said we saw it immediately. all of these swimming pools that were completely green with algae in all the foreclosed homes from the mortgage crisis. Mosquito breeding ground central. That was causing West Nile. One of the environmental factors. So, kind of always had, like I said, satellite data is a great piece of the puzzle. Not the only piece of the puzzle, even though they saw the swimming pools from satellite data, but sometimes it can be things that you just wouldn't have thought of. Speaking of West Nile, we work very closely with the Department of Health in South Dakota and Dr. Michael Wimberly at South Dakota State University on risk characterization of West Nile virus. People don't realize the highest per capita incidence of West Nile virus in the United States is in South Dakota. And so this is a huge issue to them. And what we have found is when you're looking at data like land surface temperature from MODIS, precipitation data, the strongest associations with temperature and risk of West Nile virus occur during the winter and early spring that precede the main transmission season. Basically, if you're going to have a warmer winter, you're going to have a higher likelihood of West Nile virus being more intense during the summer months. We have a video on this as well called Mosquito Meets MODIS. That if you Google for that, it'll come right up in the search engine. And not only has this provided information to South Dakota of where to spray, how to do better vector control, when to warn the public that they need to be using their DEET and what have you, but as all governments and other organizations face from time to time, they were looking to cut their budget. And they said, we might have to cut back on doing in situ sampling of these mosquito light traps. And they talked to Dr. Wimberly, and they said, could you figure out how much we could cut back on sampling and your model still be accurate? So they ran several different simulations. And they found out they could cut back about 15%. And the model was still not within 95% confidence accurate. If you cut back more than that, the model started falling apart. So, but that helped them make a budget decision as well. So you see how it plays into different scenarios. Working with EPA to improve air quality. This is again MODIS, looking at MODIS aerosol optical depth. The green areas covered in the United States are the areas covered by the EPA's air now ground sensors. But all the blue areas are not covered by the EPA ground network. So we worked with EPA Dr. Phil Dickerson to say, let's take all this ground data from air now and combine it with MODIS data in one combined product to get more representational view, a more representational view of particulate matter 2.5 micron across the United States. And so you can see this is a visible image of smoke over Missouri. And when you're running the PM 2.5 models, if you only have the ground-based data, that smoke does not show up. But if you run air now with satellite data from MODIS plus the ground, smoke pops up. And this is available to air quality managers across the United States that can log into the air now system at any time and take a look at these products. One of our grand experiments that we've done over the past several years, and this is the latest incarnation of it, is our Health and Air Quality Applied Sciences team, whose main mission is to connect NASA data and tools with health and air quality stakeholders. There's 13 members of the team led by Tracy Holloway at the University of Wisconsin-Madison. You can see their website here if you want more information. Why were they so unique? We have typically always just through our solicitation vehicles, solicited for proposals to come in for NASA on all these projects I've talked about in the past. They come in, we peer review them, and all this takes time, and then based on our budget, we pick however many we can pick out of competitive ones. But a lot of times, health and air quality issues are coming at you fast. Life comes at you fast. And people don't have time to write a proposal and get it in and do the peer review process and all this before maybe the issue's over, or maybe they moved on to something else. And the community was telling us, we really wish NASA had a mechanism to help us right now when something comes up that we need help with, somebody we can turn to. Like, if you will, the health and air quality bat signal goes up and we can pick up the phone. So we came up with the Health and Air Quality Applied Sciences team to do just that. They each have a core project that they work on over the 3-year term of the team that is much like the projects I've talked about over the past several slides. But the unique thing is that they meet every 6 months with stakeholders. The next time will be in Madison in July, where they actually sit down and say, what are your needs? What are our capabilities? Where does this Venn diagram overlap? And where it overlaps, let's all come together in a Tiger Team ad hoc project to tackle this in the next 12 months. And they have the resources monetarily and capacity-wise to do that. So it's a much quicker turnaround in being able to work with our partners. For example, one of the team members, which is, this is Haynes at University of Colorado, used NASA satellite data working with international partners to show the impact of cook stoves on health and air quality. Again, you can see here that air pollution from cook stoves currently contributes up to 500,000 annual deaths worldwide. And this was the first time ever that data from NASA satellite instruments were used to model ambient air pollution and associated health risks from cook stoves across the developing world. We can look from the ozone monitoring instrument at trends in nitrogen dioxide and sulfur dioxide across the world. In fact, President Obama featured this information in a Discovery News segment back in 2016, where, depending on where you're looking in the world, in the United States, SO2 and NO2 levels are dropping dramatically, which I'll get to that slide in just a second. Other places in the world, not so great. China and India particularly, even though China was bad for a while, but then in the last few years has actually quite a bit improved air quality. India, you're still seeing the graphs trend lines go in the wrong direction. But when you're looking at the United States, it's a huge success story that really needs to be talked about, and NASA data proved the success of EPA and all of our partners and what they've done. Nitrogen dioxide, which is a precursor to ozone, nitrogen dioxide levels have dropped 30 to 40% across the United States over the past decade. The air quality in the United States is cleaner today than it's ever been in the modern industrial age. That should be a headline in every newspaper. That's not fake news. That's real news. And you know, people don't even believe it. When CNN was reporting on this story, the cry on at the bottom of the screen said, "Air quality in the U.S. getting better?" ? And it didn't happen by magic. It happened because of our higher vehicular mileage standards, those CAFE standards. It happened because of better technology for scrubbing coal stacks. It happened also because of, to be quite honest, a revolution in the use of cleaner burning liquid and compressed natural gas in the United States. It happened because of all of these reasons combined, and it should be celebrated. And it should, because it proves the American taxpayer and the American voter that what we're doing is actually working and improving their quality of life. And unfortunately, good news gets buried sometimes in the latest tweet or what have you. So again, spread the good word that these things are working, but NASA data showed that it was working. And for the first time ever in 2016, this information was included in the EPA Air Trends Report. Again, the Health and Air Quality Applied Sciences team website, I would encourage you to go to. They just launched a new section on different tools and how-tos and tutorials on how to use different remote sensing data products, and so I'd encourage you to go there. We also have an entire applied remote sensing training program known as RSAT, and they not only do webinars, so you can do remote learning, but they also do professional technical workshops in person across all the applied sciences focus areas, including health and air quality. So if you go to their website, which is rsat.gsfc.nasa.gov, you'll see the publicly available training modules, case studies, the webinars, because we had a whole series of public health and air quality webinars over the past several years, and they're all archived there. So, and it goes all the way from remote sensing 101 to more advanced classes. And then you can also see the upcoming trainings that are going to be conducted on their website. We also have another program called Develop. The Develop National Program is for students of all ages. It's primarily for undergrad and graduate students, but we've kind of expanded it to be students of all ages. It is a competitive program run by NASA that has 3 terms, a fall term, a winter term, and a spring term, summer term, sorry. Summer term being the most popular, of course. Where you go on the Develop website, again, Google NASA Develop, it'll pop right up. And you apply to be a member of Develop. If you're chosen to be a member of the Develop team, let's say for the summer term, for example, you, depending on your areas of interest, are paired with a team of other students who were chosen, because it's a student-led, student-developed project team, with a NASA mentor at one of our NASA field centers. And you do a 10-week project to apply NASA Earth Science data to a topic, and it could be very easily a topic on health and air quality, depending on people's interests. At the end of the 10-week term, in the summer term at least, all the students come to NASA headquarters and do a showcase of all of their results that the administrator of NASA typically attends. This is just one of those projects. President Carter called up Administrator Bolden, Charlie Bolden, who was our administrator up until January, and said, we're trying to eradicate river blindness in the Western Hemisphere. The only place that's left is along the Brazilian-Venezuelan border areas. And we're working I always like to make clear, we're not working with the Venezuelan government. We're working with the Carter Center and with Doctors Without Borders. They were the primary partners. Because the Doctors Without Borders wants to know where are the remaining isolated villages, because river blindness can be treated and cured, where we can go in and develop and deliver the medication that they need to finally wipe this out once and for all in the Western Hemisphere. But we need to know where those isolated villages are, and we have to know it, because they're indigenous tribe, Yanomami. So we actually handed the program to our students. And in the summer 2015 term, developed students using different types of satellite data, including high-resolution satellite data that we had archived at NASA Goddard for a totally different project and purpose. Found evidence of 167 potential villages in the study area. We delivered those results to the Carter Center in August. They were so thrilled with the results. We expanded the project to a larger study area and continued it with a second developed term in summer, no, I believe spring 2016. Yeah, we continued through early spring 2016. And so they're using that data, working with Doctors Without Borders to help deliver that medication more accurately. So that's just an example of one of the student projects that goes on every year. And like I said, very quickly, I know I'm running out of time. Over the next 5 years plus, we have to keep that constellation of satellites robust. The satellites don't last forever, and we want to, continue pushing the envelope on new observations we can get. So when you're talking about health and air quality, the three launches over the next few years that are most important to us is TEMPO, tropospheric emissions monitoring of pollution. The instrument itself is being delivered in 2018. We're going to launch it to geostationary orbit, along with a commercial, hitching a ride on a commercial satellite vehicle. No later than 2021, this will be our first geostationary satellite looking at air quality and how air quality changes diurnally. And again, you might say, hold on a second, you said that it was very important to have these global data sets, that's why you didn't do geostationary. Well, we're working with partners. The European Union's Copernicus Sentinel-4 will be in geostationary orbit looking over Europe and Africa. And the Korean GEM satellite will be looking at these same types of observations from a geostationary orbit over East Asia. So we will have global coverage from 3 geostationary satellites looking at issues of ozone, NO2, and formaldehyde. We also have Maya, the multi-angle imager for aerosols, that the instrument will be delivered in 2020 with launch very shortly thereafter. Maya is the first purely applications health and air quality mission. It is in partnership with the EPA and the CDC, along with the World Health Organization. What makes Maya so exciting is that Maya is going to be targetable, to be able to actually target and look in high resolution detail at issues such as particulate matter in over 20 megacities worldwide. 20 megacities that have a lot of data on cardiovascular diseases, respiratory emissions, so on and so forth. So that the CDC and scientists on this mission can take that targeted PM data from orbit and try to correlate it with respiratory distress emissions and cases in these 20 megacities across the world. Also, when we would have, let's say, a large wildfire situation, Maya will also be able to target that. So it's going to be a really exciting mission. And the last one, led by Barry and Moore at the University of Oklahoma, is our GeoCar mission. It will be our first carbon observing mission from geostationary orbit as well. Currently, we have the Orbiting Carbon Observatory that's in low Earth orbit, looking at carbon sinks and sources across the globe. But this will be our first one that will actually be on geostationary orbit and launch sometime after 2020 when the instrument is delivered. But with that, I'm going to stop there. I know I've only left y'all like 5 minutes or so, I'm sorry. But if you want more information, please visit our website at appiedscientist.nasa.gov, and can always email me at jhaynes@nasa.gov with any more information you'd like. Thanks so much.